cycles refer to the cycle of merging and dispersion of continents which has occurred over the geological history of the Earth. It refers to assembly and dispersal of continents, and there were many supercontinental cycles. Among them, there was one cycle which led to the formation of the supercontinent Panocean. It started with the following sequences. The development of younger Purana basins like Kurnool, Badami, Salavi and Mandel coincided with the development of Pandian mobile belt in Pan-African times, which led to the suturing of the East and West Gondwana. As you can see here, this is East Gondwana and West Gondwana. The Pan-African times, the Pandian mobile belt led to the suturing of the East Gondwana and West Gondwana, forming the new supercontinent of Panocean. And the dispersal of this Panocean supercontinent led to the northerly migration of India, which led to the Himalayan formation. As you can see over this diagram, the Indian subcontinent was over here, attached to the Antarctica. The dispersal of this Panocean supercontinent led to the northwestern and then northern migration of the Indian subcontinent with a slight rotation until during the Cenozoic time it actually collided with the Eurasian plate, which led to the formation of the Himalayas. In the Middle Cretaceous, the collisions between the oceanic extensions of the Indian plate began with the Eurasian plate or the neighboring plates. And at that time, the sediments at the shelf areas of the Indian subcontinent and the collision zones were several thousand kilometers apart. But this gap gradually decreased when the continental part of the India closed in and the shelf and the peripheral tectonic basins had come close to each other. It was the time of late Eocene. In the compressional design provided by the collision, several zones were formed. This is the shelf zone which adjoined the terrestrial part of the subducting plate, and this is the slope region which extended off from the shelf region and went towards the deep basin. In the deep basin, the basin floor actually sank down this overriding plate, and here it is the mobile ring of mountainous areas which actually led to the formation of the Himalayas. In early Miocene, we get a fauna of the sea type, which was recorded mainly in the Darjeeling foothills along the Tista river section, and from the Miocene we enter the Neogene period, and that's the time when the Cretaceous was completely withdrawn. In the middle Miocene, the actual episodic uplift of the Himalayas took place. The Himalaya actually rose into great heights, and it also led to the southward dispersal of coarse plastics, sands and mud, which characterized the older formations of the Cenozoic period. Now let us look at the fauna because it gives us an insight about how the Himalaya rose. We can see from the fauna that the plant taxa migrated from the Mediterranean, Sino-Japanese and Malayan regions because there was a high elevation of the Himalayan range which had occurred by that time. Further rise of the Himalaya also led to colder climate, lesser precipitation and increased dryness, due to which you can see the plants which could adapt to that climate sustained, like pinus and suga, and moisture-loving plants like Dipterocarpus and others perished or moved away to the peninsular area. It could not sustain in that harsh climate. In Quaternary period, we see remarkable fall of sea level in the Indian shelves and its subsequent rise, and there was a very brisk rate of uplift of rocks. Now we come to my second topic of boundary problem in Cenozoic history. Before discussing my topic, I would like to make you know what is actually a boundary problem. Boundary problem refers to the conditions in which major geological changes has taken place, like tectonic activities or appearance or disappearance of flora and fauna, which we get to know about studying the fossils, and they are helpful in demarcating areas. Whereas boundary problem refers to those conditions studying which we actually come to know that this period period belongs to a different time period, and that stratigraphic portion belongs to different time period. So at first we look at the KT boundary or the Cretaceous Tertiary boundary. In the Theria area of Assam, you can see that the KT boundary falls in an ecologically homogeneous marine sequence about 11 meters below the top of the Mahadev formation, and this boundary is taken at the extinction level of a fossil which is Glomotrancana stewart. Also, the occurrence of extensive conglomerate in the Langford formation above the Cretaceous sediments defines a definite time gap between the Cretaceous and the Tertiary. Now let us look about three formations, Subathu, Dakshai and Kasoli of Himachal Pradesh. We will see how these three formations differ in fossil assemblage and tectonic formations, and then we will try to decode their time period. We see in the Subathu formation palynological assemblage, that means spores, pollens, dinosaurs. These can be found besides foraminifers, ostracods, mollusca and bryozoans. Also, the oldest tertiary mammal Isterium subathensis was also found in this formation. But unlike the Subathu, in the Dakshai we see it is partially fossiliferous. There are no fossils at all. Very slight amount of fossils consisting mainly of plant mutations, stress fossils of worm bats and birds. In Kasoli we find Imnio, palm leaves and well preserved fossil flowers. So we can see how the fossil assemblage is changing over the three formations. Also, in the Subathu, we see it represents the oldest rocks of the Paleogene succession in the lesser Himalayas of Himachal Pradesh. And Dakshai lies over Subathu over a variational contact with no ions. But Kasoli, in the Dakshai-Kasoli contact is marked by a tephra or pyroclastics of a volcano. Now, by looking at these things, we can infer about the paleo environment, which is in the Subathu it was shallow marine to partially brackish water environment. Rather, in the Dakshai, the flora is indicative of moist to dry tropical forest. Also, in the Kasoli, it is indicative of dry tropical forest environment. So, at last, we come to know about the time period in which the three formations lie. The Subathu falls in the lower to middle Eocene, which is in the Paleogene period. In the Dakshai, it is late Eocene to Oligocene, and in the Kasoli, it comes under Neogene, upper Oligocene to lower Miocene. Thus, we enter the Neogene period. Next, if we look at the Oligocene or Miocene boundary, that is Paleogene and Neogene boundary actually. In Assam, the end of the Oligocene period was marked by a gentle differential movement, as a result of which Shillong Plateau and Milking Hills were elevated to a higher level. Thus, we get a tectonic formation point. Next, we look at the streams or the rivers, maybe the Brahmaputra, Subansiri, Manas and Santok. We see that they become very active and reach the early Miocene coastline, close to latitude of 26 degrees zone. This is also a formational point. And here also we see that in the Assam-Bangladesh region in the eastern sector, the major Himalayan uplift is marked by the presence of a regional unconformity at the Oligocene-Miocene boundary. So these are the things which led us to the differentiation of that period, the Oligocene and Miocene boundary. In the end of Miocene, it is indicated by the extinction of an angiosperm dipterocarpus, which actually flourished in the Miocene period. It suggested that in the Miocene period was basically tropical and rainforest condition, and the end of the period is marked by its extinction. Also in the later part of the Miocene, coal and lignite development was restricted to the eastern, southern and southeastern sectors. So we can also find coal and lignite formations in that Miocene period. And finally, Pleistocene boundary. It has been defined on the basis of evolutionary changes in the fossil biota. That's the same point, the fossil assemblage. Particularly the foraminifera, the appearance of land animals and climate changes. And in Indian basins, the entry of Globonotalia truncatulinoids denotes this boundary. That's it. Thank you for your attention.